In this video, we're going to do some extra examples using Gauss-Jordan elimination method. So let's jump right in. So the first system we have is x plus 2y minus 4z plus 16w equals negative 15. And 2x plus 4y minus 6z plus 26w equals negative 26. So we're going to put this into a matrix. So it's going to have 2 rows and 4 columns, and then our vertical line, and then 1 more column. Negative 26. Okay, so we're going to start in the top left corner, pivot around that 1. Okay, it happens to already be a 1, so we want to make this a 0. When we're making zeros, we want to do use another row. So we're going to use row 1. So I'm changing row 2, so it goes first. And I want to subtract 2 of row 1. Okay, so I can write row 1 in right away because it's not changing. Okay, now row 2, I'm going to do row 2 minus 2 row 1. So this one's going to be a 0. 4 minus 2 times 2 is also a 0. Negative 6 minus 2 times negative 4, so that's negative 6 plus 8, that's going to be a 2. 26 minus 2 times 16, so minus 32, that's going to be negative 6. And negative 26 minus 2 times negative 15, so that's negative 26 plus 30 is going to be 4. So I'm done pivoting. I'm done pivoting around this entry, so I move down 1, over 1. So this is where I want to try and pivot. Okay, it's a 0 though. So I can't pivot there. So I'm supposed to look down, okay, but there's nothing below. So what I do is I move over further. Okay, so that means that this one is my new pivot. So we want to first make it a 1. So I'm going to do row 2 divided by 2. So I divide everything in row 2 by 2. So I'm going to get 0, 0, 1, negative 3, and 2. And then I'm still pivoting around that 1. So I want to make this 4 a 0. Okay, so what I'm going to change row 1 by adding 4 of row 2 to it. So row 2 is not changing. And then the 1 and the 2 in the first 2 spots, I'm going to be adding 0 times 4 to them, so those ones aren't going to change. So those are both 1 and 2. Negative 4 plus 4, that's going to be my 0. That's what I wanted. 16 plus 4 times negative 3, so that's 16 minus 12, that's going to be a 4. And negative 15 plus 4 times 2, so plus 8, that's going to be a negative 7. So now my method says I should go down further, but I can't. Okay, so this is where we stop. Okay, that's the end of our Gauss-Jordan. Now, these columns with the leading ones, okay, that's column 1 and column 3. Those are going to be called leading columns, okay, because they have these leading ones. That's the first one in any row. The other columns are called free columns. So the variables associated with these two are free to be whatever they want. Okay, so we want to remember that it went x, y, z, w. Okay, so y and w are free to be anything. So what we do next, we're going to have infinitely many solutions because we have free columns, at least one free column, and no bad row. So my next step is to write what the equations are now. So that's going to be 1 times x plus 2 times y plus 4 times z equals negative 7. And then z minus 3w is equal to 2. So you want to rewrite these equations so you solve for the non-free variables. So I'm going to solve for x and z. So x is going to be -7 minus 2y minus 4z. I lied here. Sorry. That should be a w. Okay, and z is equal to 2 plus 3w. So that means that our solutions, there's infinitely many of them. They're going to be given by, so when we write our solutions, you always want to have each variable equal to something. Okay, y and w are free, so we normally write any value. Okay, they're equal to anything. Once we pick them though, x has to be -7 minus 2y minus 4w, and z has to be 2 plus 3w. So this is the form that we need for our solutions. Okay, so there's infinitely many solutions here. Okay, let's try another one. So here I have 3 equations. So I'm going to have 3 rows in my matrix. So -4, -18, the line, and then 5. So that's row 1. Row 2, -2, -4, 10. And then my last one is 1, 4, 1. So I want to pivot around this entry, which we could do because it's not 0. But if we look down in that row, you'll see that we have a 1. So if I divide this row by -4, I'm going to get fractions. Okay, these things are not divisible by -4. That's fine, okay, but then you're going to have more fractions to deal with. So I'm going to start instead by switching row 1 and row 3. So I'm going to move this nice row up to the top, 1, 4, 1. The middle row stays the same. And then the old top row is now my new bottom row. And now I'm pivoting here, but I have my 1. So my next step is to make the things below my 1 a 0. Okay, so I'm going to do both of them. So I'm going to change row 2 first. So that I want to add 2 of row 1. Okay, so this is going to be a 0 now. -4 plus 2 times 4 is going to be +4. And 10 plus 2 times 1 is going to be 12. Okay, I also want to make the row 3 have a 0, so I want to add 4 of row 1. So now that one's going to be 0. -18 plus 4 times 4, so plus 16, that's going to be -2. And 5 plus 4 is going to be 9. Okay, so now I'm done pivoting in column 1. So I move down 1, over 1. Now I want to pivot here in this 4. So I'm going to do row 2 divided by 4. So that's going to be 0, 1, and 3. Okay, so I'm still pivoting there. So I want to make the things in that column a 0. So in my next step, I'm going to change row 1 by subtracting 4 of row 2. Okay, so 1 minus 4, or 1 minus 0 is 1. 4 minus 4 is 0. And then I'm going to have 1 minus 4 times 3, so minus 12. That's going to be -11. Okay, I also want to change the negative 2 in row 3. So I'm going to add 2 of row 2, and then I'm going to get 0 and a 0, and then I have 9 plus 2 times 3, so plus 6. So I'm going to have a 15 there. So I'm done row reducing because I pivoted here. I should move down and over, okay, but I hit the line, so I know I'm done. I also know I'm done because I see this row. Okay, what's going on with this row? So what does it actually mean? So this row says 0 times x plus 0 times y equals 15, which means 0 equals 15. So it makes no sense. This is what we call a bad row. Okay, so what that means is this system has no solution. So we're done with that one. There's no solution there. Couple more to go. So we want to solve this system. Start by writing it into a matrix. So 1, 0, negative 2, 5, negative 1, 1, 3, negative 6, 2, 2, negative 1, 5. Okay, so we'll pivot here. So I want to make the things below it 0. So I'm going to do row 2 plus row 1. So in this step, I'm not changing row 1. Okay, so if I add them, so 1 plus 0 is 1. 3 plus negative 2 is also 1. Negative 6 plus 5 is negative 1. Now I'm also going to change row 3. Here I'm going to subtract 2 of row 1. So that one's going to be a 0. This one's still a 2 because I'm subtracting 0. Negative 1 minus 2 times negative 2. So that's negative 1 plus 4. So that's going to be a 3. And then I have 5 minus 2 times 5. So that's going to be a minus 5. Okay, so I'm done in column 1. So we go down 1, over 1, and I want to pivot there. So that's my new pivot. Nice, it's already a 1. So I want to make the thing below it a 0. So I'm going to do row 3 minus 2 of row 2. Okay, so those are going to be 0. 3 minus 2 is 1. Negative 5 minus 2 times negative 1, so that's plus 2. That's going to give me a negative 3. Okay, so now we're still pivoting here. So I want to make the things above it into zeros. So I'm going to do row 2 minus row 1. Okay, so that's going to make that one a 0. So I have negative 1 minus negative 3, so plus 3. That's going to give me a 2. And then I want to do row 1 plus 2 of row 3. So this is going to be 1, 0, 0. And I have 5 plus 2 times negative 3, so that's minus 6. So that's going to be a negative 1. So we're done now. There's nowhere else to go. And now we see that we have diagonal form. So 1's on the main diagonal, 0's everywhere else. So here we have one unique solution. Okay, and the solution you can read from the last matrix. So remember the variables went x, y, z. So row 1 says 1 times x plus 0 times y plus 0 times z equals negative 1. 0 times x plus 1 times y plus 0 times z equals 2. 0 times x plus 0 times y plus 1 times z equals negative 3. Okay, so the zeros go away. So essentially we get x equals -1, y equals 2, and z equals -3. Okay, so that's our solution. Now the nice thing about this chapter is we could check our solution. Okay, so I can plug this in to our original equations. Okay, so the first one is x minus 2z equals 5. Okay, so if I put in x, so -1 minus 2 times -3, that's -1 plus 6, that is 5. Okay, so that one works out. Equation 2 is -x plus y plus 3z equals 6. Okay, so if I check this one, I have -1 plus 2 plus 3 times -3. Oh, -6, not +6. Okay, so that's 1 plus 2 minus 9. So we do get -6. Okay, now the third equation is 2x, 2y minus z equals 5. Okay, so we check this. It's 2 times -1 plus 2 times 2 minus -3. So that's -2 plus 4 plus 3. So I get 7 minus 2 is 5. Okay, so all of this solution satisfies all three of our equations. So we know that it is our solution. Okay, one more. So here's my matrix. So let's put it into the matrix. Okay, so again, because I want this 1 up there, I'm going to switch the rows. So I'm going to switch row 1 and row 3. I could have done this right away if I'd noticed. So 4, -3, 1, -9. So I'm pivoting here. Okay, so I'm going to do row 2 plus 3 of row 1. Okay, so this is going to be a 0. 2 plus 3 times -3, so it's 2 minus 9 is -7. Okay, and then I have -1 plus 3 times -2, so that's -1 minus 6 is also -7. And 6 plus 3 times -9, so that's 6 minus 27, so that's going to be -21. Okay, now I want to do row 3 minus 4 of row 1, so that one's a 0. So -3 minus 4 times -3, so -3 plus 12 is going to be 9. 1 minus 4 times -2, so 1 plus 8 is also 9. And then -9 minus 4 times -9, so -9 plus 36 is going to be 27. Okay, so we're done in the first row. So we go down 1, over 1. Now we want to pivot here. Okay, so that's our pivot. So I'm going to take row 2 and divide it by -7, or multiply by 1 over -7. So that row is going to become 1, 1, and 3. Okay, we're still pivoting there. So I want to make the other entries a 0. So I want to do row 1 plus 3 of row 2. Okay, Okay, so that's a 1. This one's going to be a 0. Now I have negative 2 plus 3 is a 1. And then I have negative 9 plus 3 times 3. So negative 9 plus 9, that's going to be a 0. Okay, now I want to do row 3 minus 9 of row 2. So it's going to be 0. 9 minus 1 times 9 is 0. So that one's also 0. 27 minus 9 times 3. So that's 27 minus 27. So that one's also 0. So I'm done pivoting here. So I should go down 1, over 1. Okay, I want to pivot here, but it's a 0, so I can't. So I should look further down, but I can't. So I further over, the line blocks me. Okay, so I'm done at this point. So we're done pivoting. Now this row here is not a bad row, because what it says is 0 times x plus 0 times y plus 0 times z equals 0. So that's 0 equals 0. There's nothing wrong with that. Okay, it means that the system had more information than we needed, but nothing bad happened. So the first 2 columns have leading ones. So those are leading columns. Okay, the third column does not have a leading one. Even though it does have 2 ones, okay, they're not the first ones in that row. So this is the first one in row 1. This is the first one in row 2, and there's no one in row 3. So that means that this one is a free column. And because the variables go x, y, z, it means that z is a free variable. Okay, and we're going to have infinitely many solutions here. So we write down our equations. So from the matrix we have x plus z equals 0, and y plus z equals 3. So if I rewrite these, solving for x and y, I have x equals negative z, and y equals 3 minus z. Okay, so here we have infinitely many solutions. Since we have a free column and no bad row, and we can write the solutions so they have the form, okay, x equals y equals z equals. So z is our free variable, so it can be anything. And then x has to be negative what we pick for z, and y has to be 3 minus what we pick for z. So that's what our solutions look like. And if you pick a random z, okay, so any z you want, okay, and then you determine x and y using these formulas, then you can check your answer and plug it into your initial system and it will work. Okay, so that's our solution here. So those are some extra row reduction examples.